Question 8. Here we have an object whose temperature is T degrees Celsius. After T minutes, the object is removed from a heat source, and they are related by the equation T equals to 55 times e to the power minus 0.1 times T plus 15. For the first part of this question, we need to find the temperature of the object at the instant it is removed from the heat source. When the object is removed from the heat source, at that very instance, T equals to 0. That means no time has passed by. So let's write T equals to 0. Therefore, the temperature T equals to 55 times e to the power 0 plus 15. But anything to the power 0 is 1. So we can write T equals to 55 plus 15. 50 plus 15 gives us 70. So the temperature would be, let's write T equals to 70 degrees Celsius. So our first part of the question is done. Now let's move on to the second part of this question. For the second part of this question, we need to find the temperature of the object when the time equals to 8 minutes. That means after 8 minutes, what is the temperature of the object? So using T equals to 8, time T equals to 8, we can write temperature T equals to 55 times e to the power minus 0.1 times 8, then plus 15. So using the calculator, we can see, or we can get the value of the temperature T equals to, let me calculate. Here it is 39.7 degree Celsius. So the second part of the question is done. Now for the third part of this question, we need to find the time required for the object to reach the temperature to 25 degrees Celsius. So using temperature equal to 25, we can write 55 times e to the power minus 0.1 times T, then plus 15 equals to 25. Now let's subtract 15 from the both side. So in the left hand side, we get only 55 times e to the power minus 0.1 times T, and at our right hand side we get 10. Now it can be written as 55 over e to the power 0.1 times T equals to 10, which again can be written as e to the power 0.1 times T equals to 55 over 10. Now let me draw a line so that I can write on the other side of the page. So yeah, okay, now let's continue. We can write e to the power 0.1 times T equals to 5.5. Now let's take ln in the both sides. So we can write ln e to the power 0.1 times T equals to ln 5.5, which can be written as 0.1 times T equals to ln 5.5. Why could we eliminate ln from the left hand side? Let's see why. If ln e base e, its value is 1, the value of ln e base e is 1, so ln e base e to the power n will be n. We use this rule. That's how we could write our left hand side. So let's make t as a subject. So we can write t equals to ln 5.5 divided by 0.1. Now let's use calculator, and using the calculator we get the value as 17.04. You can keep 17 as well. So our final answer is t equals to 17.04 seconds. Wait a minute, here time is in minute, not in second. So let me correct this mistake. Sorry for the mistake. So let me erase this. Now let's write minutes here. 17.4 minutes. So we got our final answer as t equals to 17.04 minutes. So third part of this question is done. Now for the last part of this question, we need to find the rate of change of temperature with respect to time when time is 16 minutes. What does that mean? It means we have to find dt over dt equals to what when t equals to 16. dt over dt sounds funny though. Let's write the equation. T equals to 55 times e to the power minus 0.1 times t plus 15. Now let's differentiate this equation with respect to time. So we can write d over dt of temperature T equals to d over dt of 55 times e to the power minus 0.1 t plus 15. So in the next line we can write dt over dt equals to 55 times e to the power minus 0.1 times t minus 0.1 plus 0. So how could we write this? Let's revisit the concept of differentiation of e to the power ax. d dx of e to the power ax equals to a times e to the power ax. We use this rule. So let's continue. dt over dt can be written as minus 5.5. So let's write minus 5.5 times e to the power minus 0.1 times t. Now when t equals to 16, our dt over dt becomes dt over dt can be written as minus 5.5 times e to the power minus 0.1 times 16. Now let's take the calculator again, and using the calculator we got minus 1.11. That is the rate of change of temperature when time t equals to 16 minutes. So question 8 is done. Now let's move on to the next question.